So this is Unit 3, Lesson 5 of our Pre-Calc 12 class. The unit is called Exponential and Logarithmic Functions. The lesson is called Graphing Logarithms. So in this lesson, we're going to learn how to graph a log function, and we're going to learn about the characteristics of the log curve. All right, so given the function f is defined by f of x equals log base 2 of x, we can graph this thing. If I just pick in, starting with some numbers, I want to find x values that are going to be exponents. I'm sorry, the x values are powers of 2. So I want to pick any power of 2 as my inputs. So 2 to the power of 0 is 1. So 1 would be my input, and that power is 0, that exponent 0 would be the output, because log base 2 of 1 is 0. It's really helpful to think of this as an inverse of exponential. So 2 to the power of 2 is going to be, 2 to the power of 1 is going to be 2. So if I put 2 as my input, my output will be 1. Log base 2 of 2 is 1. And if I do 2 to the power of 3, 2 to the power of 2, that gives me 4. So 4 as an input, log base 2 of 4 would be 2. Yeah, and then 2 to the power of 3 is 8. So 8 would be my next input. 8 log base 2 of 8 gets me back to 3. It might be easier to just plug in from 0. I think 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. And just work with the inverse function. That might make it way easier to graph. Although the only difference between the exponential 2 to the power of x and log base 2 of x is that the input and the output are in reverse columns. So if this were graphing 2 to the power of x, then f of x and x would change columns. But since it's the log base 2 of x, then we have the inverse of that. So anyways, here we go. If we graph this thing, 1 goes to 0, 2 goes to 1, 4 goes to 2, 8 goes to 3. So just the right side of this curve kind of looks like a radical function, but it's different because as you go left, we have negative y values. And so if we plug in 1/2, we get negative 1. If we plug in 1/8 or 1/4, we get negative 2. And we keep having the distance every time we go down 1, having the distance from our y-axis. Since we're having the distance every time we get closer to the y-axis, we're never actually going to reach the y-axis. We're just going to get infinitely close to it. And so by definition, x equals 0 is going to be a vertical asymptote. So we have a vertical asymptote at x equals 0, which tells us our graph is always to the right of the y-axis. So our domain values is from 0 to infinity, not including 0. Or we could write it x is strictly greater than 0. Our range, our y values, we can get any negative number, any positive number on our curve for y values. So our range is all real numbers. Admittedly, we're going to get to the negative numbers way quicker than we are going to get to all the positive numbers, because this curve is pointing down really quickly, but it's pointing up at a much flatter slant. Even so, it's still going to eventually reach infinity. Okay, examples. So if I have this graph and I want to graph a log function, I want to see what is in the log function. So base 2 of what? Log base 2 of what? Or what is x plus 4? This x plus 4 tells us many things. First and foremost, it tells us the vertical asymptote is when this thing equals 0, because 2 to the power of nothing equals 0. So x plus 4 equals 0 happens when x equals negative 4. So x equals negative 4 is our vertical asymptote. That's right there. Also, I want to find values of x plus 4 that give me log base 1 of 2, log base 2 of 2, and log base 2 of 4. if I could find those x values that give me where x plus 4 is equal to 1, 2, and 4, then I can find 3 easy x values to graph. So x plus 4 equals 1 when x equals -3. And that's because -3 plus 4 is 1. So if I want to graph log base 2 of 1, I'm going to use -3 for x. If I want to graph log base 2 of 2, I'm going to use -2 for x because -2 plus 4 is 2. And if I want to get the log base 2 of 4, then I'm going to use x equals 0 because 0 plus 4 is 4. So with those x values, I can evaluate my log base 2 of x plus 4 minus 1 for each of these x values. So it would be basically doing log base 2 of 1 minus 1, log base 2 of 2 minus 1, and log base 2 of 4 minus 1. Well, that's 0 minus 1, 1 minus 1, and 2 minus 1. So we have our outputs of -3 goes to -1, -2 goes to 0, and 0 goes to 1. If I plot those 3 points, and I know where my vertical asymptote is, then I can draw my curve going up, steep line on the left towards the asymptote, and more like a radical function looking thing to the right above the x-axis. So takeaways, we've now seen and have a decent idea of how to graph a basic logarithmic function by hand. And really we also are pretty much done with graphing log functions. We're not going to dig into this anymore in this class, but hopefully we build a little bit of understanding of how to evaluate with the log function when we graph these things. We also know how to find some key characteristics of a log function on a graph. We know the vertical asymptote, and we know how about the domain and range.